I was testing the mic. That was just a mic check joke. Are we doing good on the mic? When are we ready to start? Oh, we are. Are we good? All right. Well, I want to welcome everybody to the room. I think I have a mic here. You folks can hear me? Great. And hopefully the folks online can hear us as well. Welcome to the second session in a 3-session day. We just wrapped up a conversation about decarbonization, but we're going to start this meeting with safety first. Duck, cover, and hold if there's an earthquake, right? If you don't live in California, get to know your neighbor. They might be from the state and they can share with you what that all means. But I also want to say there is an exit here on my left, your right. There's an exit behind us on my right, potentially on your left. We will go out the main doors and you actually assemble where you turned into the parking lots, regardless of what entry you came into, along that sidewalk. So we kind of congregate there, and that will be where we assemble in the event of emergency. Any questions about that? Anything to add? Small cable up here. They taped up a little bit earlier to keep us from tripping. So thank you so much for being here. This is going to be about O&M efficiencies and emissions reductions opportunities. And those problem statements are in this big book, 143 pages worth. And I hope you do take an opportunity to read that. I'm Aaron Resendez. I'm an engineer in grid innovation R&D. I got a couple of my esteemed colleagues, Monique and Stefan. I'll let them introduce themselves. They will be presenting on the emissions reductions in a little bit. So we heard a lot about decarbonization. I think one of the things that I really liked about what was mentioned this morning was the transformation that all of us are in. There's a moment in time when you look around and you realize I'm part of history. I'm actually in a moment in time when I'm part of history. And this transition means that we're going from a fossil fuel-based system to one which is carbon neutral or even positive in an effort to heal the planet. And what we're going to be talking about today in this session are two important caveats that actually feed into that: emissions reductions and becoming more efficient about the way we go about our day-to-day work. So a couple of facts, and I think Austin highlighted some of these in his decarbonization presentation. I think they might have been highlighted this morning. And why are they said so often? Because they are facts on the ground we can't change, right? You notice that a lot of the conversation this morning, Elon Musk, giving his prediction, right? It's going to triple, right? The number of EVs is going to grow exponentially, right? You hear about the load, you hear about all of these things on the electrification side, which tells us that those upward trends are almost without uncertainty. And with that, that means on the gas side of the business, we're going to see a corresponding decline in the throughput. Subsequent to that, we're also going to see less and less customers left on that infrastructure. And with that, that creates certain rate pressures on them. So in order to minimize that, we want to become as efficient as we can in how we operate and maintain our infrastructure. And we talk about repurposing our infrastructure for our hydrogen economy. That means that infrastructure is going to be around for a long time to come. And so maintenance is going to be something of critical importance to us as far as how we maintain that in an efficient and effective way. So I'm going to highlight 3 areas of interest in the problem statement booklet here. And I will highlight that there is a lot of ongoing research in all of the areas that you're going to hear about today. But by no means will we locked in to just the things that we're doing. We're looking for novel solutions and technologies that help us advance these. Maybe something new that you know about that we're not aware of, or an industry partner is aware of, that we need to bring into the fold and better understand and see how we can leverage that. So this one is about the various compliance requirements, right? San Bruno was a game changer for the pipeline industry. And PHMSA responded to that by enhancing the safety requirements that pipeline operators must adhere to. And so that expansion by the Pipeline and Hazardous Materials Safety Administration was called the mega rule. And the reason why they called it the mega rule, euphemistically, is because it was a mega change to all of the various aspects within the Code of Federal Regulations that govern how our O&M activities occur in the pipeline industry. So this affected, for example, liquid pipelines as much as it affected us. And so We're seeing an expansion in scope. We're seeing that we're having to go potentially into new areas with existing technology that might not be able to fit. For example, 6 inches might be pipeline sizes that we have to start confronting, and the environments that are posed by those, you know, the elbows, the bends, the fittings, things like that, right? So one area of interest is in the crack assessment and monitoring arena. So we do periodic inspections using inline inspection tools, and anybody in the industry is probably familiar with that technology. It's a robotic platform with sensors on it that then goes through the pipe and performs the necessary assessments. That data is then analyzed, and then the output is used to make determinations on next steps, right? Be it mitigations, pipeline replacement, and the like. And so what we want to do is be able to take that robotic technology and those sensors and make them more efficient at the same level of accuracy, the repeatability, and reduce the cost of operation. Can we keep them in the pipeline longer? Can we eliminate umbilicals, for example? Things like that, right? And then can you miniaturize them? And anyone that does sort of robotic design will tell you there's certain engineering challenges they'll have to overcome. Fine. Let's talk about what solutions need to be put in place to be able to overcome these engineering challenges. And the second area is toughness verification. And I think the best way to kind of illustrate this is to tell you how that process works today. So what you have is when you want to do a toughness verification, right, of a pipeline, you have to dig and expose that pipeline. You have to then shut the gas down, because you're going to take a piece of that pipeline out and you're going to send it to a lab. So you're interrupting the service, right? Which has certain dynamics on the system from a planning perspective. And you send that to the lab and you get that information back and you take whatever action based on the results of that. Can we do that in situ? Can we develop technology that, say, for example, our crews in the field can then pull off the truck, take into that excavation while that pipeline is actually in service, and do the necessary analysis right then and there? Huge cost savings potential, huge. We're looking for solutions. Storage wells. So you heard, if you were in here with decarbonization, they talked about storage wells. For folks that might not know what a storage well is, I'm just going to briefly explain it. Most of us are familiar with where oil comes from, right? It's a geologic formation. It's below the surface. The actual gaps between individual grains, for example, of sand, hold that oil in place. You drill a well, you puncture that reservoir, if you may, you put the infrastructure on the top, and you pull that oil out. So these reservoirs and that associated well are also used to store, in this case, natural gas. And we have several of these wells. These are very common. There are plenty of wells, storage facilities across the country, right? But in order to maintain the integrity of that well, you have to shut down that well and then insert very sophisticated, high resolution technology into that well. And these wells can be a mile deep, even deeper. So it's very expensive because you're interrupting the service of that facility, and you're also taking the time in order to perform that task. Can we make that more efficient? Can we evolve the technology from where it's at, the way it's used, and make it more efficient while making it reliable, accurate, repeatable? Can we move to a space where we're actually doing real-time monitoring so that we can get accurate data at any point in time? Fiber optics is seen as a huge area of interest among pipeline operators for such an application. There's ongoing research in this space, but the question is there something different? Can we interrogate that signal such that we can get different data points from it that perhaps we can't get right now? Is there the science available to be able to get us to that point? These are the kinds of opportunities that we're looking for. And then well life estimation. So it's difficult to know. How long will a well last? How long will a well last, right? This is also a question we'd like to answer, especially in light of the absence of any sort of anomaly that puts a risk into that well that we may not be aware of, or we haven't seen for a particular well. Have we seen it at other wells? Maybe we have. Can we do the modeling that gets us to a place where we can start to understand those based on location, based on geology that well goes through, right? And then time. Over time, how might those variables change, create interactions among themselves that impact that well and its overall life? This is the kind of more academic related exercise that we foresee that this might be suited for. And then lastly, before I hand it over to my colleagues, Geo Hazards, right? Duck, cover, hold. We say that because we live on the Ring of Fire. The San Andreas Fault runs right through here. We all hear about the 1906 earthquake and other subsequent earthquakes, right? So seismic activity is ongoing and will continue into the future. How does that seismic activity, be it large or even small, you can actually see in this image post-earthquake, small traces of movement in the subsurface. Some might have been known, some might have been unknown. How is the pipeline in this image potentially impacted by those movements? We're looking to better understand and model how such movements can impact the actual pipe itself. And it goes beyond just kind of the seismic, kind of earthquake related stuff. What about climatic changes? We had some 9 or so major storms blow through California last year, dumped record-breaking snows in the Sierra Nevada. But during our wet season, which is the winter time, we also saw a huge number of landslides, some impacting our infrastructure. How do we assess the potential for a landslide to occur at any particular place? What about areas where fires have occurred in years past? Those areas no longer have the root systems grabbing onto that soil, holding it in place. How might those behave as storms after storm after storm rolls into California? We have an El Nino year coming on. One would expect we're going to see a lot of storms, a lot of rain this year, right? That's the normal pattern in an El Nino in the state of California. So how are these going to impact? And then secondly, what about the technology? So you've got, I know some of the folks in the room, you've got folks that do satellite related data analysis, so they can look at the world from the satellites and make a determination of how much the Earth is moving. You have Lidar technology, which is flown in aircrafts or on drones that can be used to assess the surface and any sort of movements. You have various types of technology that can be placed on the surface, near the surface, or even deeper, that might potentially hold a key to unlocking the mysteries of how that subsurface movement may be playing a part in the integrity of the pipeline. So these are the kinds of opportunities in this category we're looking for. And with that, I'm going to hand it over to my colleagues to talk about emissions reductions.
Here. Just a quick introduction on myself. My name is Stefan Ramos. I'm an emissions strategy group. Just highlighting what was mentioned earlier today. So Austin mentioned, Eric mentioned, we have these lofty goals within our climate strategy to reduce emissions, reach net zero by 2040, and be climate positive by 2050. Kind of looking into the near term, we do also have 2030 goals where we need to reduce our scope 1 and 2 emissions by 50%. A large part of that is going to come from the gas, and we're targeting a 45% reduction in that category. As shown on the bottom left is just a visual of what we've accomplished so far. So we've reached our 20% reduction goal by 2025, and this is all part of our Senate Bill 1371 and situ abatement OIR report program. Some of the things to help us get there is one, our damage prevention program. A second one being the implementation of the carbon, oil, and gas goal, where we do quarterly leak surveys at our compressor station and storage facilities, as well as replace all of the highly pneumatic devices at each station. The third one is our centralized LNG CNG cross compression program, where we take an isolated pipe that was planned for scheduled work, and we move that gas into an adjacent pipe or input it within a tank.
Thank you.
And another part of the emissions reduction program is how we address super emitters on our distribution system. And so we drive our entire distribution system with advanced mobile leak detection technologies where we're able to detect and repair the large emitters much faster. So what we're looking for in this innovation summit is what Aaron just highlighted earlier is novel and innovative technologies to help us to continue to reduce emissions so that we can meet these emission reduction goals. And so I'm just going to run through a series of problem statements and Monique's going to help me run through that as well. This one is focused on calculation. So our highest emitting category today is transmission, metering, and regulating stations. And it represents 30% of our emissions. And the reason for that is because we calculate it using a population-based emission factor approach, where we multiply the number of stations we have within our system times a certain emission factor. And this limits us to show any emission reductions without removing stations from the system. What we want to move towards is a more component leak-based approach where it's a lot more granular. And so what we have is a project with NICERs to better characterize those emissions at the stations, where we have a bucketed approach based on how much emissions are coming from the stations. And when we decide to rebuild or replace those emitting components, we can move that station from the higher emitting bucket to something much lower. And within our report, you would be able to see those abatements and the reductions so that we can meet those goals. Let me pass it over to Monique to run through a few more of our problem statements.
Hi, everyone. I'm Monique Montague, and I am one of the engineers on the gas R&D team here at PG&E. And I'm going to quickly go over a few of the issues that we are facing in the methane world. And so the first one I'd like to talk about is how we perform our meter set leak repairs. And so currently, the process requires our technicians to fully break down the meter set before performing the repair. And as you can imagine, this is not only time intensive, but it is not cost effective. And most importantly, it really poses a safety risk to our coworkers performing the repairs. So essentially, what we're looking to industry for help with is solutions and ideas for performing meter set leak repairs permanently on meter sets with different types of technologies. And some of the technologies we're currently looking into right now are spray-on epoxy seals, mechanical clamp styles, and even compression tapes. And so if we can bring that forward within PG&E and really repair these meter sets using these type of technologies without breaking down the meter set, we can really improve the safety aspect, repair the leaks quicker, and really reduce our methane emissions. The next issue I'd like to address is transmission and distribution leak detection. And so we have various methods in place already for performing leak survey that work very well, but we are always looking to supplement those technologies with new innovative technologies. And so the idea here is we're looking for technologies that can really enhance quantification, improve leak detection, and improve pinpointing of leak localization. And the idea here is if we can really find those larger emitters, as Stefan said earlier, we can repair them faster, hence reducing our emissions and maximizing our potential there. So some of the processes that we're looking into right now are aerial technologies. And so some of these include sensors that are mounted on drones, sensors that are mounted on fixed wing aircrafts, sensors that are mounted on helicopters, and even some forms of satellite technologies. And so again, if you have something that can supplement our current leak survey practices that really enhance the quantification piece here, please bring it forward during our pitch fest. And the last problem statement I'd like to go over is really probably our most complex that we're seeing in the emissions world right now, and that is the lack of continuous monitoring equipment that is available commercially that has the ability to be cost effective in terms of utilities, as well as really has that quantification piece. And so, as I said before, we have lots of processes in place for performing leak survey on our transmission and distribution pipeline assets, and they work very well because they're instantaneous measurements, and the emissions there are really driven by leaks. But when it comes to stations, and when I say stations, I mean metering and regulating stations and even some compressor stations, the emissions here are not necessarily driven by leaks. They're actually driven by component design. And so the need for continuous monitoring really comes into play because we need to be able to capture those intermittent releases that come from the components by design. And so again, if you have something on the market, or if you're familiar with the technology, have an idea or a solution regarding continuous monitoring for M&R stations, please bring it forward during Pitch Fest. And oops. And with that, I'd like to turn it over to questions. Thank you all so much for being here with us today. We really appreciate you taking the time out of your day to spend it with us. And yeah, we'll go ahead and open it up to questions.
Any questions online? Steve, are there any questions online? Okay, we're scooting over. We're getting the hand in the back row.
Quick question
Yes, Gary.
from Monique. When you're talking about the meter leaks, is that diaphragm meters? Is it turbine meters? Is there a specific style of meters that you're?
So all meter set leaks, but essentially what we're trying to do is find, I'm sorry, can you guys hear me? Essentially what we're trying to do is find a repair solution without breaking down the meter set. I think it's the repetitive motion of wrenching consistently on the meter sets that a lot of our technicians are worried about wear and tear on the body. And so if we can really find something like an epoxy seal or right now something that we are looking into and performing an internal study with is called alpha tape. And it's a compression style tape that you simply wrap over the meter set, and it can actually, from studies that GTI has done, hold a very good seal on a meter set leak, a small fuzz leak specifically. But the idea here is really to prevent our coworkers from going through that repetitive motion over and over and keeping them safe. David, back please, thank you.
You had done that study with NVU with the Lidar data back in 2019 through PRCI. Did you guys do subsequent passes of Lidar differencing for your Geo Hazard program?
So the question is, you were referring to the PRCI project that took place a few years ago and looking at LiDAR related work over the footprint and seeing if we may have flown those other areas subsequent to that to see how they might have moved. Not that I'm aware of. Not that I'm aware of.
Okay, so you're not collecting Lidar currently for the Geo Hazard program management and doing the differencing?
So what we've developed is a matrix internally that gives kind of what the best use case would be. So certainly in the event of an earthquake, we have flown LiDAR almost immediately, tried to get airborne as rapidly as possible. We do own our own LiDAR systems internally, on the aircraft that we actually use for our aerial patrol program. And the LiDAR is flown. It's being mostly used, if I understand, on the electric side for vegetation related aspects, post-fire related assessments, things like that.
Okay, and on the leak detection side, do you have a grams per second threshold you're looking for?
So it depends on the system you're looking at. When we do our distribution leak surveys, we had a supermeter threshold of 10 standard cubic feet per hour. We've now dropped that in 2023 to 7. And as we move towards 2030, we're going to continue to drop that and increase surveys so that we can obtain the most emission reductions. On the transmission system, we're still looking to quantify those emissions, right? So there's a limited selection of technologies that we can use and leverage where we can scan the system much faster. So we're really just trying to set the baseline there. But right now we're only using it on the transmission system for detection.
Thank you.
No problem.
We have another question on the other side of the room. Oh, we're going online. Excellent.
Yes, we have a online question. I see lots of monitoring and leak detection mentioned. What about in situ repair of leaking distribution and transmission lines? Is this something PG&E is looking for?
So generally speaking, in situ repairs is actually mentioned in one of the problem statements within this book, right? And where that comes into play is actually on the distribution side, where we're looking at mains, where lines have been buried for a long period of time. Perhaps the materials that have been used become brittle over time. And the field has actually asked, hey, are there things in technologies out there in the marketplace that perhaps can be used for in situ related repairs? I don't know if you have anything to add. Okay. So that is one of our problem statements. We're looking for innovation in that space, perhaps even using keyhole technology to the extent possible to minimize the excavation and streamline the permitting process and lessen the amount of time that it would take to make those necessary repairs.
Okay, we have another one. Who should we contact and how should we proceed to ask questions when we have specific technical questions in preparing our solutions more precisely?
Do you want to say?
So I guess that question depends, but if it has to do with leak detection and quantification or any of the things I spoke with, you can contact me. So monique.montague@pge.com. If it has anything related to O&M costs, you can go ahead and contact Aaron Resendez at aaron.resendez@pge.com. And then if you have anything related to GHG emission strategies, meaning calculations to the California Public Utilities Commission, go ahead and reach out to Stefan Ramos, stefan.ramos@pge.com.
I hope you got all those emails down. But I will also add that we do have an innovation inbox that's published inside the actual problem statement document, the strategy document itself. And we'll make sure that it gets to the appropriate people. The nature and scope of your question may necessitate multiple different groups in order to be able to fully kind of be responsive, and we want to be responsive. So that could be your first best step because that will be a very managed box, and we'll be able to document that incoming traffic and make sure that we get closure on those questions too. We have a question back here.
Hi, Austin Hastings, PG&E. One question that I have is related to the meter set leaks and then also on the distribution main and service leaks. I know that we're talking about saving wear and tear on coworkers, and that's absolutely important. But really what we're trying to get to is more of a assembly line approach in repairing these leaks, driving downwards the leak threshold that we're repairing, right? We're going from 10 to 7 down to 5, down to 3, or whatever that futuristic number is. And then reducing the cost of each one of these leak repairs, right? So instead of breaking apart a meter set, you tape it. So you go from an hour and a half to a 10-minute repair. Can you speak a little bit to how we want to make this kind of repetitive and so that we can turn these leak repairs into more of a redundant, cost-effective, kind of standardized approach in eliminating these leaks, both from a meter set as well as maybe an underground distribution main perspective?
Sure, I can go ahead and start with the meter set leak repairs. But essentially, as you commented, the idea is really to reduce costs here. And so when we've done cost studies, for example, I'm going to use the alpha tape because that so far has been a very promising method for us. It shows that you can repair about 6 leaks with one single roll, and one single roll is around $70. So as you can imagine, that is an immense cost savings if it turns out to be very promising. And so a systematic approach for this would be, we have 2 different groups that handle repairs currently with meter sets. We have both M&C and we have our field services team as well. And so right now there's kind of a delineation between the two in the sense of when the leak appears on the riser portion of the meter set, the GSRs will actually call that in for M&C. And so what we're doing to pilot that right now is if this tape solution turns out to be as promising as we foresee it to be, those repairs will actually, we will save an immense amount of money on those repairs because our field services technicians can actually perform those repairs instead of sending it over to M&C. And it won't be taking work away from M&C. They'll still have repairs in that sense, but as a very quick fix and permanent solution, this is very promising for us. And then with leak detection underground, do you want to speak to?
So I think the question was, how do you make leak repairs on the below ground leaks much faster and a lot more, I guess, efficient? So what we've seen in like some of our super emitter program and where the leak is coming from are those TCAP leaks, where half of those super emitters that we do find are from TCAPs. Aaron mentioned it earlier, keyhole repairs, where you're limiting kind of your excavation, your bell hole. That way you're able to repair that much faster at a much cheaper rate rather than excavating a larger hole or trench where you're having to squeeze and plug and isolate and ultimately do the repairs there. So finding easier means to perform the work without having to do the actual work to open up the entire hole.
Sorry, just one last comment, but in terms of the meter sets as well, to save time, you're not essentially breaking down the meter set anymore when you're performing the repair. If you're using a tape style solution or a spray on epoxy seal, it would simply go on top of the meter set. And majority of the time for our technicians is really breaking down that meter set in its entirety in order to perform the repair. So that as well would streamline that process.
Are there any questions online?
Okay, so this question is kind of blended with this first session, but are you looking at how hydrogen blending will impact the existing leak detection systems?
Yes. There is research in the space because obviously we do methane leak detection, right, currently. But there is research in that space. Perhaps Austin wants to expand on that a little bit.
Yeah, thanks, Aaron. This is on, right? So that's going to be part of the Hydrogen to Infinity project that we talked about in the previous session. Is we're not only going to be looking at materials, but we're also going to be looking at construction methods like in-service welding and tapping and plugging, as well as leak detection and leak repair as part of that overall project.
Okay, next question. Understanding there's a lack of continuous monitoring quantification technology options in the market right now, but are there any you're currently using or trying out?
Yes, so currently the way we monitor our M&R stations is we have a pilot going on and we use Sensit Technologies. They're fixed point laser sensors. And we essentially use the detection rate on that. So when I say detection rate, ppm meter, and then we transduce that into a emission rate. But in terms of physically measuring an emission rate, we don't have something on the market for that yet. There have been technologies that we've come into contact, but they are always out of the utility price range and generally targeted towards oil and gas. And so this is why we're really turning to industry, because this really is one of our most complex solutions. We have lots of stations and a lot of them have different types of actuators. And so when we have these intermittent bleed actuations, you cannot simply categorize them all as one. And so we really need to collect the data on here to get a better understanding of the emission rates coming from these stations. And so in short, no, that is really where we need industry's help with really getting together that equipment.
Okay, we have more questions. Are you applying and using any AI for your emission monitoring and asset management and efficiency?
The answer is not yet, but we would like to.
Yeah.
Okay, and this is a follow-up to one of the other questions that Monique, you just answered. But can you please identify some of the current projects you have for emission reductions? And also, who are some of the partners who are assisting with the research? It could be industry and or university partners.
So I'll answer the second question first because it's a quicker answer, but we work very closely with different research consortia that includes PRCI, GTI, as well as NICERC. And then as for the first question, right now this year, we're really targeting aerial vendors. And so we are doing some piloting with Bridger Photonics, which is a LiDAR sensor mounted to a helicopter. We are also looking into satellites And we are currently running the pilot that I already discussed with the alpha tape. And oh yeah, and then last week we did a demo with QLM Technologies. And so they have a LiDAR-based camera where they can actually see emissions visually. And so we performed a demo down at our Winters test facility along with them, as well as the CEC and let's see who else. Los Alamos Laboratory as well.
All right, one other question. Congrats on meeting your 2025 emissions goal already. Are you targeting an additional increment of reduction in the proposed new projects for meters, leak localization, and the others you mentioned?
Yes to everything. And we do have increments in which we continue to reduce our goals as we move towards and march towards 2030 and past that. Right now, I'm assigned to figure out how we're going to reach our 2040 goal of reaching net zero and what can we feasibly reduce our gas operations emissions by. So work in progress, and yeah, meter sets and leak localization, all the things you mentioned will contribute to that.
I think we have time for one more question, maybe time-wise.
Okay. And I think this is for you, Aaron. Is there new technology to capture non-matte gas lines?
There's a lot of research in that space looking at, enhanced ground penetrating radar. There's been a number of technology advancements in that space, usually adding more arrays, getting greater resolution, right? There are some kind of physics realities that have to be overcome around depth of those lines. We've looked at new research that's taking military focused and developed technology and moving it into the civilian sector that takes kind of a new approach scientifically to how to detect underground lines. Most of that has been focused on metallic lines. And of course, there's a lot of plastic in the subsurface. So we are looking at what would be more intrusive. So various insertion tools that can be put in, for example, things like that. So we're taking a holistic approach to that. I believe in the underground session, there are some of the problem statements around the locating of lines and the prevention of damage to underground lines. So it is a topic of continued exploration. There has been a lot of research in this space as well. Okay, I'm getting the signal. We have room for one more question. Is there one more question from the room? Anybody? If not, we'll take that last question from the internet.
Okay. Are you open to considering risk management principles and solutions that the banking industry and healthcare industries have been using?
PG&E is a risk-based decision-making company. We use risk modeling, risk spend efficiency, and the like to be able to make important decisions about maintaining our infrastructure. So it's already something in play in the pipeline industry and certainly here at PG&E. And I think that's it. Thank you so much. Thank you for your time. Thank you for your conversation. Thank you for your partnership.